Good evening, everyone, and welcome to the latest instalment of Agile London. Thank you very much for joining us this week. I, like most of you, I'm sure, have been very excited about this one and to kick this one off. So can I just, as per usual, go over the couple of standard house rules that we usually have? So can I just request that we all remain on mute throughout the talk? The reason I ask that is we've all joined this session to hear from Joe Justice this evening, and I really want everyone to maximize that and get the most out of it. It just helps with the fluidity for Joe to continue his talk throughout the session and for everyone to hear from Joe. I do actively encourage questions, so please do fire them into the chat at the bottom of the screen. And throughout the session, I might jump in and ask Joe one of those questions, or in addition, please again put them into the chat and I will fire some Q&A at Joe at the end of the session. So please do, be positive and be forward with your questions to me and to Joe, but send them privately to me and I will ask them on behalf of you to Joe. This session is recorded, so this will go onto our YouTube channel this evening. So feel free to sort of jump onto our YouTube channel and watch it back and share that amongst your community as well. So moving on, my name is Alex Scriven. On behalf of Agile London, I work for Oliver Bernard, who are a London-based recruitment company. But on the side, we have sort of over 4,500 members on our meetup page. And, through lockdown and through, technology, it allows us to sort of facilitate these sessions. And I reached out to Joe recently and was absolutely delighted when he gave us the thumbs up for him to sort of join our session and give a talk tonight. So just to introduce Joe Justice, he is a TEDx speaker, a guest lecturer at both MIT and Oxford University in the UK, who was featured in Forbes 5 times to date and was subject of the Discovery Channel's documentary on his work creating the disciplines extreme manufacturing, Scrum Hardware, and the Justice Method. Joe also operates at, or has previously operated at Tesla and consults globally on Agile Hardware, which nicely leads me on to his talk for this evening. So with regards to Agile Hardware, the speed of new product development and new product introduction is related to the agile management of the enterprise and the agility of the manufacturing process. The CEOs of Volkswagen, Bosch, Toyota, and Tesla all agree that speed of change is top priority. Joe Justice, inventor of extreme manufacturing and employee of Tesla, will show exactly how agile manufacturing is conducted. He will also discuss the benefits and hurdles to Agile Hardware and display the steps to implement from executive management, design, engineering, test, factory floor, and much more. Joe, welcome to Agile London. Thank you very much for joining. I'm going to hand over to you.
Fantastic, and thank you. Oh my gosh, I'm really grateful to be learning with the group, the Agile London group. You folks are practitioners in one of the world's most epic cities, and I'm glad to be sharing what I've learned, and I'm really looking forward to what you choose to teach me through the chat. So please aggressively use the chat so I can learn from you. So this is two-way. And feel free to tweet at me anytime ever. That's what you can learn from you that way. Let's see if I'm able to share slides in a window. Sometimes Zoom lets us do this. Okay, I'm going to see if I can share my screen. Let's see if this is successful. Okay, maybe. This might have worked. Do people see something that says Agile Hardware? Okay, I got a thumbs up from Alex. I got a few other thumbs up. Okay, cool. And let's see if I can get the chat open. Alex is going to prompt me when something happens in the chat, but if I can get the chat window to also stay open, I can see if there's a change or an announcement or an event. Okay, yeah, maybe I even have chat open. And I chat bombed in the Zoom chat links in case people want it. So especially if my audio gets bad, if there's an internet connectivity issue, I put an awesome sprint review video from SpaceX. So you want to see what an Agile hardware sprint looks like? I put a sprint review video link in the Zoom chat already. And how to get started. If some of you want to reboot some teams or reboot your own team, I put a link on my recommendation on how to get started. Put a link of how to work with me remotely on business with me. So thank you, and thank you. Those are in the Zoom chat. As Alex mentioned, I spent the summer working at Tesla, and I operated Agile at Tesla there from the global headquarters in Fremont, California, USA. That was during the largest stock price increase in that company's history. And that turned out to be one of the largest stock price increases of any company in the history of publicly traded markets. It was massive. So I was there when it happened and operating Agile at Tesla when it happened. And I got to learn a lot. Now, before that, I've worked at Toyota with Ariane Group on their rockets, with another rocket company in California, with some aerospace, airplanes and other rockets, Boeing, Lockheed Martin, Raytheon, United Launch Alliance, et cetera, and a bunch of military and banking. So Pictet Bank, ING Bank, well, you'll see. And I want to share what I think I've learned about what makes this stuff work. And I want to learn from you. So please aggressively put stuff into the chat so I can learn from you. First, here's my perspective on the business end of agility. This graph shows how fast new products arrive to market, and that's the black bar. And then the red bar is the company's total value in publicly traded, its market capitalization. And you see Tesla is at the top. They have 27 changes in hardware and software in production per model per week. And their market capitalization hovers right around $420 billion US, give or take, depending on the week. I'd like to compare that to Toyota, who's worth about half that much publicly traded, and their speed of change in the market, their new product development plus new product introduction, is 2.5 years on a fast-tracked product. So that's about the time it takes Toyota to change the bumper and the software and the navigation and maybe the number of cup holders, that type of change. That's a 2.5 year cycle. That's called a minor model change. BMW, Daimler, Volkswagen are a little slower. They're closer to 3 years for what's called a minor model change. So for the grille, the air intakes on the front of the BMW 4 Series and the navigation software and maybe the parking sensors to change, that's about 3 years. GM, Ford, Fiat, Chrysler are a little slower still. It's closer to 4 years for them. And you can see that's directly correlated with the total value of the company. From a publicly traded investor's standpoint, speed of new product development plus new product introduction is absolutely correlated with company value. And executives understand this. Here are some of my clients. I'm very lucky to have worked at the very top level of some of the largest companies in the world. Volkmar Denner is the CEO of Robert Bosch GmbH, 300,000 employees all around the world. And Volkmar told me, for Bosch, agility is crucial. It allows us to adjust to the increasing speed of change around us. Agility allows us to remain in a position as an innovation leader. Now, I'd like you to see what he's saying here. He's saying it's all about speed. The reason the chief executive of Bosch wants agility across the company is faster NPD plus NPI, faster new products to market. If you look, Akio Toyoda, the CEO of Toyota, who sent his son, Daisuke Toyota, to be trained by me to lead their agile transformation, says the same thing with different words. He says, when you look at a product, going to the actual sites, going to Gemba, that's the Japanese word for the place the product is made, not only the place it's planned. It might be planned too, but it means the place where it's made. He says, what is important is to fuel the change point. He's saying what's important is to make it change faster. And Herbert Dice, CEO of Volkswagen Group, where my partner works at the board level, he says the same thing. He says the big question is, are we fast enough? If we continue at our current speed, it's going to be very tough. Then Elon Musk, who was my CEO this summer, who I worked for, he says pace of innovation is all that matters in the long run. And notice, Elon Musk's company is worth more than the other 3 companies added together. That's it. The purpose for agility at the business level is, did we release product tested that people liked faster than anybody else? That's it. That's what business agility is. There's all these other warm, fuzzy reasons that we really care about, and I super care about. I'm a people first, happiness first consultant. The business value is, did NPD and NPI speed up? And the top management gets it. But it's not only in publicly traded companies. Government and government plus publicly traded companies are doing the same thing. I've had the pleasure of working with the US Department of Defense, the Australian Department of Defense, Lockheed Martin, Raytheon, Google, Amazon, Microsoft, Boeing, Hewlett Packard, Tesla, Toyota, MIT, MIT Sloan Business School, Harvard, Oxford University in England, Siemens, Unilever, and more than 100 others. These are all companies with agile transformations in the company. Depending on how you measure it, the majority of the world's currency is being managed by a company in an agile transformation. Royal Bank of Canada is having an agile transformation right now, and I have consulted to it. Their assets under management, $660.9 billion Canadian. ING Bank has posted what Deloitte and Boston Consulting Group both call the most successful agile transformation of all time. And they say, and their total assets under management is 887 billion euro. Pictet Bank is the largest privately owned bank in the world in Switzerland, and I've worked there as an agile consultant. They have 554 billion Swiss francs managed. And in US dollars, Capital One, $372.5 billion assets under management. And they are currently hiring certified Scrum Masters, if you look at their website, and certified Scrum product owners. The majority of the world's currency, depending on how you measure it, is being managed by a company in agile transformation. The reason I say this is to say we are past the early adopters. We're at the laggards and the late majority now. So agile is already the new normal. And what it looks like to me in these companies, what I want to share, is it looks like what Henrik Nieberg taught us Spotify was doing years back. Now that's a little funny because Henrik himself says the Spotify model was only a snapshot in time and it's not a model. He says that's only what Spotify was doing then. And Spotify has learned a lot since then, is doing even cooler stuff. Well, that said, what Henrik did share has gone viral and it's working. In most of these companies, what they've done is they've taken a big product and they've cut it into parallel executable chunks. I'll call that the product owner role, how to cut a big product into parallel executable chunks, into these extra small projects that can be run at the same time. And then these big companies have a whole bunch of agile teams, each with their own Scrum Masters or agile coaches and product owners, executing in parallel. Now, I did this with my car company. So I'll use my car company as an example. You see the picture at the top, that's a car that my car company builds. That's the WikiSpeed SGT01. Some people use it as a race car. Some people actually commute to work in them. That's the car my car company makes. Designing a new car is a 7 to 11 year process. Design, build, test, certification, just like Toyota, just like Daimler. Well, how to make it faster? How does agility increase the speed? If you cut it in half and you put a stable interface between those halves, by that I mean so you could build each half totally separately, and as long as they still plug in, they work. That way you don't have, one doesn't have to wait on the other. You've made them parallel buildable by cutting it in half. Well, now it is able to be done. If it was 5 years before, it is able to be done in 2.5 years. That actually works. And if you cut those halves in again, and then again, so now you have 8 pieces, you can now finish the new car in 3/4 of a year. That works. But then how do you get which is already awesome, right? So modularity is already the name of the game, mass parallelization. Well, how do you get even faster than that? That's where all these other agile practices that you folks on this call come in. That's where you help companies after that, or you might help them modularize their product. Then you help even more. And that's with stuff like DevOps, automated testing in hardware and software. That's stuff like customer in the loop for rapid decision making. That's stuff like agile money management and agile budgeting on a sprint cycle instead of annual budgeting. That's agile HR. That's lean agile procurement. It's all the stuff you know super well. Better cross-team communication with less or DAD or Scrum at Scale or Scaled Agile, etc. They all work in different ways. That gets the time down more, to the point that we have these teams releasing once a week, or in Tesla's case, once about every 3 hours. Hardware, like, let that sink in for a moment. This is what it looks like inside. And there are new cars, changes in production, hardware and software, about every 3 hours. Okay, so you have tribes and guilds or whatever you need for cross-skill communication across module teams. But the heart of it, I think, what I'm observing is you cut the product. And it is big. It's a huge thing. It's a car or a rocket or a jet or a boat or a building or a financial service or an answer to digital currency, whatever the big project, we cut it into parallel executable chunks. And then if you have enough people, which these big companies do, then they have teams or teams of teams work each of these chunks in parallel. I was lucky enough to work directly with Bill Gates. And I want to share with you what I was able to learn from Bill Gates. Every single meeting with Bill Gates, he started with, how much of this can be built in parallel? Every single time, 100% of the meetings I was in with Bill Gates started with him saying, how much of this can we do in parallel? And that seems to be true. So this slicing for parallel execution, I believe, is the first step. Paul Takin rolled out the same thing at ING Bank. And this is what I did at Wikispeed in hardware, and then with other companies since then. Now, regulatory bodies have given us examples of waterfall phase gate approval processes. This is a picture of the United States Code of Federal Regulations, the law of what's required for new medicines or robotic surgeries or electronic devices to be implanted inside humans, for that stuff to be approved. The FDA, the Food and Drug Administration in the US, governs that: medicines, robotic surgeries, implantable electronic devices. And they show this waterfall diagram. We're going to start with preclinical trials, then have investigation, new drug application, then go to phase 1, phase 2, phase 3, new drug application review, FDA approved results. It looks like Prince 2 or the V model or any standard phase gate dependent flow. So how can you be super fast? How can you release products in 1 week sprints when you have an 18-month or longer approval process? Well, these regulatory bodies worldwide are now publishing Agile certification methods, saying, here's how you approve your product in a week. And I'd like to read this part of the law to you. This is published law. This is the current law in the United States now. The development process depicted in the example is a traditional waterfall model. The design proceeds in a logical sequence of phases or stages. Basically, requirements are developed and a device is designed to meet those requirements. The design is then evaluated, transferred to production, and the device is manufactured. Makes sense so far, sounds like waterfall. The law continues. In practice, feedback paths would be required between each phase of the process and previous phases, representing the iterative nature of product development. Interesting. The law says we're actually not going to work in sequenced phases, we're going to work in iterations. Starts to sound more agile. The law continues. Although the waterfall model is a useful tool for introducing design controls, its usefulness in practice is limited. The model does apply to the development of some simpler devices. However, for more complex devices, a concurrent engineering model is more representative of the design processes in the industry today. Well, now we have concurrent engineering, which means we're testing at the beginning. Test-driven development is now explicitly encouraged. And I'll say user acceptance test-driven development or business value test-driven development. I'll add that. And we have design happening parallel with production and test. Starts to sound like a sprint, doesn't it? And it's iterative, so it is a sprint now. And they go on to say the device history file, which says which process you use, whether it's waterfall or not, they say the audience of that is the manufacturer anyway. Like they don't even really care what process you say you use. They just want to know that you wrote down whatever process it is. And as a result, there's now publications like Agile in FDA and regulated environments. And we're seeing this in aerospace all around the world, not just the US. Medicine, surgeries, implantable devices, Neuralink, for example, et cetera, et cetera. We're seeing long test at the end phases no longer being required and incremental test first approaches being accepted. So regulatory bodies are less of or no longer the bottleneck. I'd like to show what it looks like inside. Here's Volkmar Denner saying agility is their recipe for speed across Bosch. This is 300,000 people worldwide. And here's what their Agile hardware transformation looked like. Step one, Volkmar Denner called my mobile phone. Thank you so much. What an honor. And he said, please fly to Stuttgart. I want you to executive consult to me on our Agile transformation. And I did. I flew to Stuttgart. This was pre-COVID, so we met in person and had one-to-one executive consulting. Thank you so much, Volkmar Denner. He then had me give a keynote presentation to the 500 top managers of all of Bosch's 300,000 people. Immediately following that keynote of what Agile hardware can be, I did what's called leadership workshops with all of them in small groups. Then step three, I went directly to work with the product teams. What you see on the left is 1 week of work from a product team. So they just launched a week ago. This is their sprint one review. What they've done is taken a rangefinder, a stock Bosch part, and they created a custom bracket and some custom wiring and attached it to the front of a freight locomotive, a freight train. So this is Thomas the Train Engine in real life, full size at the customer site. It's a real customer operating freight locomotive. And they have their Bosch rangefinder on the front. And they're getting customer feedback. And the customer feedback in 1 week was, yes, this is actually preventing some of the time we run over tools that people forgot on the track in the train yard. And it's reduced the number of times, even in 1 week, that we bump shorter carts that park in the train yard. Because it's hard to see out of the cab when you're that high up and really near something. And they said, yes, this is a good thing. Here's sprint 2, 3, 4, and 5. In sprint 2, the team at Bosch found that rain and snow was confusing the sensors. They were getting beeps even when there wasn't an object on the track. So they installed a windshield and a wiper, which reduced that confusion. In sprint 3, they installed many more sensors and had a wider range of sight and a larger windshield and a larger wiper. By sprint 4, they had custom circuit boards. They made some in-house and they sent out to have others made. And they also were now 3D printing their own enclosures. And they were able to have the sensors packed much tighter together on the smaller circuit board. So they had a smaller windshield and a smaller wiper. By sprint 5, the software was now working so well with the sensors that it compensated for the enclosure and it compensated for weather. They no longer needed a wiper or a windshield at all. And sprint 5, they went to market, they went for sale. The point I want to make is in every 1 week sprint, there was new hardware and new software tested at the customer site. So Agile hardware, a lot of slow companies think Agile hardware means we're going to have planning in sprints, we're going to have designs in sprints, and we're going to meet each of our phases in sprints. And they still have 2.5 year long new product development cycles. That's not what I'm talking about. I'm actually talking about splitting these really large projects, like a rangefinder for freight locomotives, into 1 week sprints or even faster, and testing real hardware and software every 1 week sprint. Now that does mean excellent engineering practices. That does mean testing every day with a suite of automated tests. It does mean DevOps. So you have scripts and physical robots automating some of your assembly. That's what it means. And when you do, it goes super fast. Here's what it looks like in Tesla. The picture of the inset is me as a full-time employee at Tesla's global headquarters in Fremont, California. Then the main picture is, it's called the marriage. This is the step where the Model X, the big SUV, is put together. And I'd like to show you what's going on here. There are 27 changes in hardware to these cars in a week. So the robots have flexible hands. In most manufacturing steps, the robots have a fixed grip to hold one part for years, for 2.5 years or 7 years when they make the same thing. It's cheaper that way. Well, when you have 27 changes a week on these products, the robots have flexible hands so they can be programmed multiple times a day to hold different parts. So first, there's flexible work holding. Second, the parts themselves are designed with interfaces. They're mostly flat. You can see these mostly flat mating surfaces. They're not all flat. These interfaces allow the parts to change anytime without disrupting neighboring parts. That way, the teams that's working on one part can deploy a new design multiple times a day, and they don't have to time it with changes to the other parts. Now, that said, interfaces do change at any time, but the people working on both sides of the interface have to agree when they're going to change. Otherwise, the parts won't fit together. Now, this is compiling. For those of us with a software background, compiling, when the software gets translated to machine code from our higher level language, this is compiling in hardware. It's when robots combine the high level design pieces into physical goods. This has to take less than 5 seconds, so that the timing, the feedback loop, is fast enough so there's not a queue of bad cars. Because imagine there's new parts being deployed multiple times a day, right? Well, if one of them fails, they don't integrate, they don't fit together, the build breaks, the car doesn't assemble. You don't want a queue of cars that can't assemble. So this has to be ultra fast. This step is completely automated. So you know in 5 seconds or less, did it compile? Did it fit together? And if it didn't, exactly one car loops back to be reassembled as the previous version, which we've just rolled back to build. That's fast rollback, just like in app development. So that way you can change any time because there's fast rollback. So there's at a maximum one bad car that needs to be looped back for remake. Now, I've tried to sum up this idea here. Automation in software and hardware and management with test in the loop is in fact the answer. Humans are for creative problem solving. Automation is for everything else. In Toyota, manufacturing uses what's called single one-piece continuous flow. If you look down at the factory, trucks unload and pieces get assembled bit by bit by bit in a line, and it goes out for testing, and then once it's been tested, it ships. Now, since Toyota tries to reduce variation, 6 Sigma, right? They try to have minimal variation. They don't need to test every part. They test about 1 out of every 1,000 because they have minimal variation. If one part in a batch passes, it's very likely all parts pass. That's super efficient for manufacturing. Toyota is great at this. The downside is if you want to make a change to the design and the product, you have to reevaluate the entire lean flow. This is why a product changeover shuts down the plant, often for several months, as the plant is retooled to make the new version. So in exchange for high build efficiency, pace of change is slow. So I'd like to show you what a company like Tesla does. Again, if we're looking down at the factory space, there's going to be different parts coming to assembly multiple times a day, right? So having a single one-piece unload of parts doesn't make sense. Instead, there's what's called a stock backplane. It's a wide array of different types of parts that could be used with minimal stock because some of it might never be used again in the next version, right? We don't know. It's going to change multiple times a day. So there's a minimum amount of stock of a wide variety of types. It's like a grocery store. It's like a supermarket. And then you have humans pushing and pulling carts and automated robotic carts getting what the team needs now. And what they pull changes a few different times a day, right? So they have agility. That's then pulled to agile teams. And these agile teams have what are called prototyping lines, where they actually build the thing. They design and build the thing every day. Now, here's the interesting thing. These prototyping lines are the production lines. They just keep making it. Like, it's the same. So you have these prototyping lines doing new design, but they do it really fast, or they try to, and it's heavily automated. So if the design is working, it just keeps working. And you have a whole bunch of these in parallel. And that's production. This is volume production. Now these teams, since they're changing often, remember when I showed the robots putting the Model X together, and I said it needs to be less than 5 seconds, or else if you have a failed design, you want to avoid having a queue of cars made of a failed design. So there's this thing called a stock front plane, and that's this integration step, the compile step. And that fast feedback loop needs to happen so all the teams know if their current design is working. And that's what has to be 5 seconds or less. And because it's massively parallel, it's actually faster than single one-piece continuous flow manufacturing. This is single one-piece continuous flow manufacturing, the Toyota production method, was super cool for its time. But that, if you think about it like a computer processor, that's single-threaded processing. That's the slowest type of processing. That's like a 286 12 megahertz chip in your factory. This massively parallel approach, this is like a Core i7 with Hyper-V and virtualization. You have mass parallelization. This is like using AWS or Azure. It's tremendously faster, and it's faster to change. And this is what we're seeing in manufacturing now. If you want to go deep on this, I highly recommend Paolo Samichelli's book, Scrum for Hardware. Now, embarrassingly, the first half of the book is the story of my life and his life. I will say skip the first half of the book and read the second half, which is the technical practices that actually make this work. So I highly recommend the second half of Paolo Samichelli's book, Scrum for Hardware. This is what my own car company did. This is how I learned this stuff, was by doing it. And we did set 4 world records. The practice was, if it's a standard operating procedure, if we just want to do the same thing again, automate it. Groups of humans are for all the stuff that's not a standard operating procedure. And in London, there's a restaurant doing this. It's Ricardo's Restaurant on Fulham Road in Chelsea. And they do this. If there's standard operating procedure in the restaurant, they automate it. And humans are for all the creative problem solving. And as a result, this restaurant is so good that when I was there having dinner, Princess Kate Middleton was 2 tables down celebrating her birthday. She ordered the salmon, the tuna fillet, as she always does. That's how good this restaurant is, and it's totally run with Agile methods by Riccardo Meriti, and uses this method. These pictures are building one of my cars with Agile methods, and they did it with new design in 27 minutes, which was a world record. This works in construction too. Here's a hospital being built in 3-week sprints. In the United States, building a new hospital typically takes many years. When COVID happened, many municipalities said, we want more hospital bed space right now. And they said, who can give us more hospital beds in 3 weeks? And companies that had said, look, it's a 5-year project, it's a 10-year project, suddenly said, okay, we'll do it. And so here's what it looks like. Here's Agile Hardware and Construction. They took the largest module size that you can drive around on the street. You can deliver by road. And that's, sorry to use imperial measurements only, it should be metric, but that's 8.5 feet wide, 13.5 feet tall, and 40 feet long. In the US, you can take that on any road legally. So that's the module size. And each module has hospital beds, heating, ventilation, and air conditioning, and a hallway piece so you can walk through these things together. And they design and build them done in 3-week chunks and deploy them. And to scale up, they set these things next to each other and stack them on top of each other. And you have construction in 3-week sprints. So yes, to go this fast, I do believe it requires modularity. And this is, of course, what huge companies like Tesla are doing. Here's a picture of the Gigafactory in Sparks, Nevada. And I think I have a better picture. Yeah, here's a close-up. This factory isn't its final shape yet. Its final shape is like a big hexagon, basically. They build it square by square, but this picture, you can see the next square being built, and here's how Tesla does it. First, as soon as they buy the land, they put up a tent. And that tent is for production. There are people in the tent designing, doing engineering, and building, in this case, batteries in the tent. Then a construction crew comes in as soon as they're able and starts building the next factory cube, the next factory XY module around them with real-time feedback from the people designing and building batteries. That way, what's being constructed, the factory, has live real-time feedback from the people doing the work. So this is unusual. The work is typically not done until after construction is complete, but that's not at all how Tesla does it. So engineering is already being done in a tent, and production of the factory happens around the tent. When the factory construction is complete enough, the tent is taken down and engineering simply continues. Same day, no disruption. Everyone doesn't have any days blocked. They just keep working, and quality and volume go up. If quality and volume don't go up versus working in the tent, the inside of the factory is gutted and it's built again with better feedback, because the only reason to have built that building around the tent is to increase quality and volume of production. So those are measured, right? If quality and volume don't increase by building a building, they're not going to build the building. They're going to be lean about it. They'll just stay in the tent, which, by the way, they do for the Model 3. The Model 3 is still built in a tent because building a building around it had no increase in speed or quality. So you start with a tent, do the actual work, build the construction around you per module. Then the next module of the factory is built next. That's modular XY construction. Here's modular Z construction. Here's an active office building, well, and production facility at Tesla's global headquarters. This is right by where I was working. And a new building is being built on top with feedback from the people working in the building below. So true Agile, right? Customer in the loop, full-time, daily changes. And here's really how it starts. This is even before the formal tent is erected. See all the shade covers? They're blue and green mostly, and tarps even. This is mostly loading and unloading of stock, but this is also engineering and production. When people pull using a pattern called Metascrum, when they pull their next priority, what's the next most important thing to do, they simply start work anywhere there's physical space to do it. It's a lot like what cells look like inside a living being. And they simply start work under a shade, or sometimes they don't even have a shade. They simply start work. And if the quality and volume justifies it, they start building modular XY and modular Z construction. There's no phases is what I'm trying to say. It's not like there's an approval phase and then a planning phase and then a design phase. No, it's you start that day. In fact, you start that hour. And then you concurrently plan, do you need manufacturing facilities built around you? This also works in aviation. I've been lucky enough to work with the leadership team in engineering, procurement, validation for the F-35 Joint Strike Fighter, the F-22 Joint Strike Fighter, the Saab Gripen multi-role strike fighter in Linköping, Sweden, etc. John Spruce, I don't know if he's on the call, but he's also London-based. He's worked on the Loyal Wingman product with agility. Here's the leadership team of the F-22 and some of F-35. Here's the F-22 and F-35 team building a car in 45 minutes. The Agile training for them in hardware to speed up this aircraft, I said, well, let's build a car in sprints. And they're like, how would you do that? And we just did at my house in Linwood, Washington, just north of Seattle. And on the left in the red shirt is 3-star Air Force General, retired Ken Merchant, who now leads the F-35 project. And in that team, this is what's called a full stack team for an Agile transformation. There's all the lead engineers for the F-22 from Boeing and Lockheed Martin. There's all the business leads from Boeing and Lockheed Martin. There's the procurement lead from the US Air Force. How many of these planes are we going to buy? And there's the US government oversight committee leaders to say, are you buying them in a legal way? They're all there in the same room. Now, if you're lucky enough to have a full stack leadership team who can make all decisions on what are we building, how are we building it, and how many are we going to buy, you can change everything you need to. You can actually have the full feedback loop and do Agile hardware. Now, for those of us that aren't lucky enough to be working with the entire leadership team, the scope of the transformation is only the scope in which we have executive sponsorship. So if only the software leads are bringing you in, Agile London practitioner, that's the current scope of the transformation. And if they have a hardware product, we can't expect it to magically get Agile unless the leads of the hardware group decide they want to, right? So that's the stack leadership team. This here is the head of software, Bjorn, for the Saab Gripen. And he says something really cool about hardware. Reconfigurable means we can add applications without having to requalify the platform. What he's saying is the Saab team got permission to add new applications, new software to the Gripen multi-role strike fighter without having to test and requalify. They could simply fly it. What he then says next is they can actually even add new hardware. Now that's funny, it's coming from the head of software. So he talks about hardware like it's easier, but he says we can actually even add new hardware without having to retest the plane. That's what you have to do if you're gonna launch a new plane, fly a new plane every 3 weeks, which Saab does. They work in 3-week sprints, it's Scrum across the entire organization, and they fly new planes every 3 weeks. Now, how they got that permission is they run full certification tests every day, 24 hours a day. And so it's a massive test effort. But by deploying that massive test effort where entire certification tests are done every single day, they were able to get permission to fly a completely changed aircraft every 3 weeks. And then they're able to iterate, and they do. They have a pace of iteration in hardware, in jets, with software too, that looks like they're making apps. Now, when your product changes every 3 weeks, like Saab Gripens does, it now makes sense to have these other really good Agile practices like customers on site. So there are 8 pilots full-time on site at Saab because the product changes fast enough to keep their interest. If you have a new Agile hardware initiative and the product is changing every 6 months, it's not interesting enough or useful enough to have these Agile practices like customer on site. But when the sprint length gets less than a month, which is the maximum sprint length for a project to be called Scrum, by the way, is 30 days is a maximum sprint according to the Scrum guide. Now these other Agile practices make perfect sense because it's changing fast enough that customer feedback is warranted. This works in commercial and cargo too. I've been lucky enough to work with Boeing on the new model aircraft and with Mitsubishi on the Mitsubishi regional jet. The Mitsubishi regional jet was ultimately canceled. They weren't able to roll out Scrum across the project. They experimented with Scrum to try to save it. The leadership team ultimately decided not to do a transformation, unfortunately. But the new model aircraft for Boeing is absolutely full steam ahead, last I heard. Here's how I do a transformation. I wonder if this is helpful to you. Please put in the chat where you think I'm not right, where I could be better, or what you do so I can learn from you. I start a transformation by doing an all hands survey from the people doing the work. And they say, here's how we say we're doing the work. Then there's an activity called a leadership workshop where leadership now gets the survey results. Here's how the people doing the work say they're doing the work. Let's have a retrospective, and we run an Agile retrospective on what's the gap between how the people say they're doing the work and super fast new product development plus new product innovation, NPI plus NPD. That gap, the retrospective output, that's the backlog of the Agile transformation. And that's why it's different for every company, because it's the actual steps to close the gap from wherever they are, which is unique for each company, to super fast NPD plus NPI, which is the business value of agility. Now, I'm happy to say the way to get there has everything to do with respect for people and an excellent place to work that's safe, psychologically safe, and all the soft values of agility. But those are in service of, I think, the business value, which is faster NPD and faster NPI. Then everyone goes through a certified Scrum Master and certified Scrum Product Owner course for management, hardware, and software. Now, you could, anyway, that's how I do it. Then every team has a Scrum board, so I know what they're working on, who to talk to about prioritization, who to talk to about flow or impediment removal, and who to talk to about quality. Then all teams roll up under a group Scrum board. Now, a link I put in the chat is how to have thousands of teams in a group Scrum board. So you have an at-a-glance view of, are we building the right thing? Are we building it cost effectively? And is our quality adequate? Which are the leadership decisions I need for executive-led agile transformation. So we use a group Scrum board for that. Meetings every day. And we end up having company as a service teams supporting the module teams. So there's a coffee team. Yeah, there's a funding team to make sure everyone has enough money. There's a food team. There's a facilities team to make sure we all have the right tools. We split big projects into a lot of little projects. The way the companies restructure is called Justice's Law. This is one of the two things that has been named after me. And Justice's Law states the modules of the system define the structure of the organization. Or put more simply, the modules of the product define the structure of the company. So we don't have an engineering group anymore, or a mechanical engineering group anymore, or a procurement group anymore. We have module teams that include mechanical engineering, software engineering, product design, product validation, and they run in parallel, this massively parallel concurrent deployment. This is where the speed comes from. And it is a complete restructuring of the company. And here's me at SpaceX World Headquarters in Hawthorne, California, and you see them doing it. The Falcon Heavy is an extra large project. It's the largest rocket that's operating in the world right now in terms of kilograms into orbit. And how they build these things is 3 Falcon 9 rockets make a Falcon Heavy. So 3 large projects make this XL. A Falcon 9 rocket is 9 Merlin engines. A Merlin engine is an extra small project for SpaceX. And Elon Musk has famously said they've never made 2 Merlin engines the same way ever. Every single one is an experiment to try to improve. So when 9 Merlin engines are done, they have a Falcon 9. When 27 Merlin engines are done, they have a Falcon Heavy. They've split an extra large project into 27 parallel executable extra small projects. That's the name of the game. That's how this works. Standish Group has told us small agile projects are the least risky anyway. And now every project can have a sprint burn down chart in terms of these extra small projects. And now we can have large release burn down charts. I've got a whole bunch more data, but I think you get the idea. I'm going to stop share because we're at 51 minutes after the hour. And I'm going to propose homework for everybody. Homework would be to go to LeanPub and look for Paolo Samichelli's book, Scrum for Hardware. There's a free preview. And I'd request that tonight before you go to sleep, you read page 13 and 14. That's it, 2 pages. Oh, let me see if I got the pages right. I want to make sure it's important. Yeah, page 13 and 14. It's free, it's part of the free preview, which is the first chapter. Page 13 and 14 gel the technical practices behind what I'm talking about. If this is at all interesting to you, please go to LeanPub, search Scrum for Hardware. You'll see Paolo Samichelli's book, download your free sample, read page 13 and 14, then go to sleep. I think so much more of this will make deeper sense. It'll be more immediately actionable to you if you're interested. Thank you so much. You're amazing. Now I'm gonna have Alex share with me all the magic that's been happening in the chat so I can learn from you. Thank you, thank you, thank you so much.
Joe, thank you very much for that. That was absolutely fantastic. I especially drew more interest to the strike fighter jet section of your talk. Really enjoyed it. So some questions have come in, Joe. First one, do you think Tesla's focus on quick delivery goes some way to explain the perceived lack of quality of hardware? Do you think some companies find that balance of quick delivery versus delivering a quality product is difficult?
Oh man. All right. I'm going to try to answer this honestly and in a useful way. So Reuters News in London has been publishing strangely negative press about Tesla for years, including stuff that's not even true about quality. So Tesla sells out. They sell out completely on all counts success. And Reuters writes Tesla runs out. They pivot the words. They say Tesla runs out. They say Tesla can't keep up. Like if BMW sold out all the possible 3 Series they could make, that would be amazing. Tesla sold all the Model 3s they could possibly make, and Reuters writes they can't keep up. They have production issues. It's bizarrely negative. And what it's done is it's helped suppress the stock price of Tesla. Now, when I joined Tesla as a full-time employee, in my first week of employment, Reuters suddenly changed the narrative, suddenly started typing really positive stuff about Tesla, strangely positive, even untruly positive stuff about Tesla. Not only was Tesla's quality suddenly super high, according to Reuters, but no other company can keep pace with Tesla. Tesla is so far ahead in autonomy, in production capability. They even went so far as to say Tesla is a salient investment. And what happened to Tesla's stock price? It went up 5x. Same Tesla. Tesla was doing the same stuff. The quality was the same as it was the week before. Reuters started writing different press. Now, also interestingly, after the Tesla stock split, which is when many of the banks in London changed their positions, they'd made the money they wanted to make, they just went up 5x on Tesla, and they started to reinvest in coal and other legacy petroleum, environmentally harmful products. Suddenly, Tesla's making the same products. Reuters starts saying Tesla's hazardous. They're beta testing on their customers. Same Tesla, different Reuters press. And right now is a great time to buy Tesla stock because Reuters is very happy with trying to drive down the Tesla stock value. What I do want to say, in objective measures of quality, Tesla leads. And this is important for us as Agilists because there's a perceived exchange between speed and quality. And we can't, as professionals, we cannot have inadequate quality. It's not safe. So we have to only look for speed where quality stays high or increases, which is what Tesla is doing, by the way, but you wouldn't know that by reading Reuters and all the other news outlets that pick up Reuters pieces. Because Reuters has vested interest in the financial markets, like most media does. But what's important for us as Agilists, regardless of what you may or may not believe about Tesla and press and media, is if speed is going up but quality goes down, we have to retrospect and reevaluate, period. Otherwise, we'd make unsafe product, which is not going to scale and will lose the business. And by the way, Tesla's quality leads Daimler, leads Lexus, leads BMW, and so does their safety and all of them, by the way. But regardless, it's going to be automated test for high quality only for speed. And there's no exchange between speed and quality.
A classic example of don't believe everything you see or read in the media. Next question. For a software product, we usually use BDD to specify acceptance criteria and to build test automation. What methodology have you used to specify behavior, acceptance criteria, and test automation when it's for hardware components?
Same, I use BDD. Now, there's two other buzzwords, but they mean the same thing as they do in software. In software, you've got to test if your connections between software modules, that your APIs, you've got to test your APIs, and you've got to test your APIs against boundary conditions and for security and scalability and all the illities, right? Maintainability, are the APIs clear enough? Well, in hardware, we have funny names for our APIs, you know, the places where hardware pieces connect. And we call that finite element analysis, or FEA. And that's how strong are the interfaces and how strong is the module itself. And then we have another one, CFD, computational fluid dynamics. And that's how well can we take data which is heat, really. Data is heat. And then all forms of heat and fluid exchange. So cooling, electrical information, conductivity, et cetera, et cetera. That's CFD. And airflow around the part, or fluid flow around the part, et cetera. So FEA and CFD, these funky buzzwords that we hardware people really like, that's test automation in hardware. And we absolutely use BDD to say, how much heat exchange do we need between the battery pack and the motor module? How much heat exchange do we need between the driver's butt and the driver's seat? All this stuff, every interface, just like in software, how every interface breaks down into data exchange, in hardware, every interface breaks down into FEA or CFD. That's it. So you have awesome CFD and FEA modeling and automation, and that's what design is in hardware. And you robustly automate those and have self-learning. This is where big ML, basic machine learning, is super valuable, creating random permutations of part analysis and never stop running tests. So that way you develop a library of materials that have passed the test, which means you're not dependent on a test phase even when you change design. You've already tested, does that adhesive work with that alloy? You know, because you've had this random exploratory testing running 24/7 in mass in the cloud, and physical testing. But yes, that. It's BDD. Short answer, yes, it's still BDD.
Another one. Any innovative approach requires environments that's equally compatible. Often companies seek influences for the essentially non-agile cultures, still pretending or truly believing they are. The blockers are political. What would be your approach to circumnavigate that / avoid, attempt, engage with gusto?
Man, unfortunately, I've only got what I believe to be the truth here. And that's by my summation, the most agile, or one of the most agile companies on the planet. And by that, I mean their NPD plus NPI speed. So let me use that as an example of this question. If Bentley somehow bought Tesla, which they couldn't because Tesla is worth more than 100x what Bentley's worth right now. But if Bentley somehow got out of the Volkswagen group, and so it was its own company again, and bought Tesla, Tesla would not be able to release 27 times a week. So what does that, if I'm right, what does that tell us? It's a leadership team decision. It is. If Elon Musk was ousted from Tesla and you installed the leadership team from Renault or Peugeot or BMW, Tesla would slow down. So it's a leadership team decision. And I think our job as Agile London is putting more good information in places where leaders like to read and helping organizations understand how to be more flat. Because as an organization becomes more flat, it's less of a leadership bottleneck. It's less of a cult of personalities and hierarchical brittle structure. But if the leadership team changes, the agility of the organization changes. And it's one-to-one that. So get those people into your Agile classes, get those people into your, if you do it, certified Scrum Master class, or whatever it is that conveys what you know about agility. And until we do, the company is only as brittle as their choice. What I've found works well there is what I tried to share in this talk, an all hands survey of how the people doing the work actually say they're doing the work, and then a retrospective with leadership team on that, with what's the gap between how the people say they're doing work and fast NPI plus NPD. That gives the backlog I need for the Agile transformation and the leadership understanding and the leadership buy-in. And it creates that Agile culture at the top tier. That's what I got.
Thanks, Joe. This next question refers to when you were talking about the 8 permanently employed fighter pilots and the continuous upgrades that happen for the planes. So a member of the audience has asked, in these examples, do all modules change in sync?
No, that's where the known stable interfaces that's where they help us, right? If you open up a remote control for a television, it probably still has AA or AAA batteries inside, or a standard format battery, right? That means the company making the batteries can deploy new battery chemistry, which they do completely separately from the pace that the remote control company makes remote controls, right? Because there's a known stable interface between those two things. That means the parts can change out of sync. Now, that said, if you want to change the interface, if you want to switch from a AA to an 18650 super long lasting lithium ion battery, which some remotes do, so they last a super long time, that has to be in sync. Now, that change can happen at any time, but then the group making the batteries and the group making the remote control have to synchronize when that change happens, when that release happens.
Thank you. Joe, how do you forecast requirements around people's skills to support a wave agile delivery?
I love this. Thank you so much. And by the way, Murat says, gotta jump. Very illuminating. Thank you, Joe. Thank you so much, Murat. And there's a good comment. Thank you, Eldred. Thank you, Sophia. Thank you, Rajesh. Thank you, Mara. There's so many. Thank you, everybody. I use self-organization. I have whoever's funding, which in some companies, that's the employees themselves. If they self-fund, if they're a flat organization, or if it's investor-led, I have the investors, whoever's funding, post what is funded. What have we agreed to fund? I have them post it on a virtual poster board. Before, we did this physical on giant whiteboards in great big rooms. Now we do it through tools like Gather, where you can have thousands of people online moving around virtually. And what's funded gets put on the virtual wall. And then I ask, as the facilitator of this self-organization, teams, please self-organize around the goal you're most excited about. Then look around at who joined you, discuss if you have the right skills to design, analyze, build, test, and deploy this thing with quality and speed. If not, negotiate to trade players with other groups. And it takes about 15 minutes, and we've restructured the company. Oh, did I freeze? I saw Eldred move. Eldred and I are connected. Eldred, it's you and me, buddy. Oh, Brianna, got you. All right, we're together. Oh, Mike, I saw Mike move. Okay, I'm still here. Alex, did we lose you? Did I lose you? Alex,
yes,
come back.
It looks like he's not here.
Oh man. Okay, well, while Alex reconnected, it is 5 after the top of the hour. So folks, please stuff anything in the chat you want me to learn from. I want to learn from you. You can tweet to me anytime, and I've so far answered every single tweet that @s me. So if you wanted to say something, please also consider doing it there.
Hello, everyone. I am back. Yep, I froze for some frustrating reason at the time. Glad to see we're still there. Okay, I can jump to the next question. Hopefully I didn't miss too much. How the company manages innovation versus sustaining. How do you carve out time to get ahead while ensuring shipped products are supported and maintained?
Oh, yes, please. Okay. In a full agile company, which is what I'm talking about, right? And some of us aren't there. I get that. I empathize with that. Some of us have NPI phased gate funding cycles, and it's going to be a little different depending on the state of the agile maturity of the company. But I'll talk about it from the holy grail, the destination state. It's just items in the backlog. So the backlog says, look, we need to upgrade the heat pump so we can take it from the Tesla Model Y and put it in the Model 3. That's sustaining and innovation, right? Then the next item says water gathers in the bumper when there's high pressure water, like a car wash. Let's fix that. That's the next backlog. Well, that's sustainment. And the solution to it is innovation. Like that's all it is. It's a backlog of what is funded. And we choose to fund whether it's sustainment or innovation, and we just put them in the backlog in order. Now, a lot of companies aren't that agile yet. I respect that. And they'll have separate sustainment backlogs, separate new product innovation backlogs. They'll even have separate groups execute each of those backlogs. They might even have separate companies. We outsource sustainment, but we do new product development. Those are dysfunctions. Those are unhealthy. But if that's what we've got right now, that's what we've got. So in that case, I bring whoever funds those two backlogs together, if they'll let me, and I do what's called meta scrum. I execute the meta scrum pattern as authored by Jim Copleen and Kiro Harada and Joe Yoder, and many other folks involved in that pattern. I execute meta scrum across the prioritization of those disparate backlogs. And I've just been made host. Thank you, Alex. Okay. I feel all powerful. Someone just asked to join in from the waiting room and I clicked admit because somehow I became host. So thank you. Folks, you are all amazing. Read the chat. Anything you or answer to? Do you think? Thank you. Ask at the end of phase 10 questions to me privately and ask at the end. Okay. The analog of a bug in hardware Agile would be a part which just doesn't work and breaks everything. Yes. How do you go back and construct a part at the same Agile cadence you're trying to achieve it as in 3D printing? We've got to use fast rollback. So we don't do mass manufacture until we have one part that works, right? A car that works. So now that's in mass manufacturing. And let's say we deploy a part with a bug, as you wrote, as Murat writes. So it breaks the build. It doesn't work, right? Well, we revert to the previous part because we have a previous working part by definition, or we wouldn't be in mass manufacturing. So we revert to the previous version as we redesign. And redesign takes as long as it takes. It might take 10 minutes. It might take 10 months. Redesign takes what it takes. But as soon as that new part is ready to try again, we deploy immediately. There's no phase gate to wait. It passes the unit test. Now let's do integration test. And exactly one car is, because compile is so fast, exactly one car gets it before we know if the next car should get it or not. And we loop that defective car back for remake or not. So how this works is fast rollback to the previous part, Murat. Thank you for your comment. FEA and CFD are computational methods. Do you test in hardware too? Yes. Now, hardware testing is typically slower, sometimes weeks or months. So hardware testing is treated like an outsourced operation, and it's constant. It's a 24/7 operation, and it's as massively parallel as possible. So what we don't want to be doing is testing individual parts. Then we have a dependency. Instead, we want to test materials. So how does this alloy work with this adhesive? How does this lubricant work with this adhesive? That's constant, 24/7, months long. And what results is a library of materials we know work together, regardless of what shape those materials are in. Now you can build those in whatever shape you want. So you pull from the catalog of approved materials that have gone through materials test and make parts out of them. And that's super fast. And hardware testing in parts, then those long running tests we don't have to do because we know how the materials behave together. That's the long running test part. Doing fatigue analysis of a known alloy in a specific shape is completely unneeded. A lot of companies do it for safety reasons. No, they're just slow. So you don't have to do long running tests on the individual parts. That's where the speed gets unlocked.
Hi, Joe. I'm back. I've got full connection now. Have you, I think I lost some of the chat. Are there any sort of further outstanding questions there that you can see that I haven't covered? I think I might be up to date.
I think you are. There's a request for slides, Alex. Alex, if I can get those slides to you, where can you put them so people can access them?
Would you be able to, are they able to, we could maybe do some sort of hyperlink to them or something. If me and you will talk about that, and then I will post a message to the community combined, and they'll all sort of get the message at the same time to see how they can access those slides. We can talk about that. If you're happy to, of course.
I've got a sneaky idea. Let's see if this sneaky idea works. Yeah, I think it's going to work. Here's my sneaky idea. Oh, yeah, okay. Bam. In the chat, I've just put me talking through these slides at a slightly faster pace. I didn't say everything I said here, but it's these slides are almost similar at a conference I gave. So this is private because the conference has rights to post this for the next like 30 days. You can sneakily see these, and then after 30 days, you can share it publicly. Let's say at the end of November, that'll work. At the end of November, you can share these privately. You
what
can share
I'd
these
say as
publicly.
well is this recording and this whole session again will be on our YouTube channel, so people will be able to refer to it and watch this over and over again should they need to. Joe, I just want to say thank you very much for joining us tonight. It was absolutely fantastic to just hear from you and sort of give you the platform to speak for Agile London and our London community. It doesn't happen without speakers like you, and it doesn't happen without our audience. So thank you to everyone else who's joined as well. Yeah, just really want to say thank you very much. We'd love to have you back and talk with us again in the future. So we'll talk about a second date there. Yeah, I mean, just from Agile London, thank you for joining us. I work for Oliver Bernard. So if you are looking for work or you are looking to hire anyone, I'm not that difficult to find on LinkedIn. So do reach out to me and I'll do my very best to help. But Joe, just want to say thank you again once more. It was a really great session. And yeah, we will catch up with you very soon.
Please, everyone, consider connecting with each other and me too. Please LinkedIn me and each other. Please Facebook me and each other. Please Twitter me and each other so that we can stay this global community helping each other change the world. Please do connect with me. Please do connect with each other. I hope to have a flood of invite requests on Zing, LinkedIn, Facebook, Twitter, and I hope everyone does from each other. Thank you, everyone. When COVID's over, if it's ever over, let's all have a beer or a coffee together. Thank you, everybody.
Thanks, Joe. See you soon. Bye, everyone.
Thanks, Joe.
Thanks, Joe. Have a good evening, everyone.
See you all. See you next time.
Thank you. See you at Ricardo's London on Fulham Road in Chelsea.
Or an Agile London in person when we can all do that, because usually these are in person. So, Joe, if you are ever in London and we could coordinate you to do an in-person Agile London talk, we'd absolutely love that. But I'm going to go and grab some dinner. Joe, you go and get some lunch.
Guys, thank you very much.
Thank you.
Brianna,
See you later,
good to see
everyone.
you.
Bye-bye.